Imagine standing on the surface of the moon, not as a visitor, not as a tourist passing through, but as someone who lives there. For 60 years, that idea lived only in the pages of science fiction. But in March 2026, something shifted. NASA didn't release a press statement. They released a declaration, a roadmap, a hard-edged, step-by-step plan to build a permanent human settlement on another world, and to do it within a decade. No more flags and footprints. No more, we came, we saw, we left. This time, America is going to the moon to stay, and what they've put together is unlike anything we've seen since the Apollo era. Only this time, the technology is real, the mission is funded, and the clock is already running. Stay with me, because by the end of this video, you're going to see exactly how humanity plants its first permanent roots beyond Earth. Phase by phase, year by year, piece by piece. Here's what most people don't realize about where we've been. For the better part of a decade, the Artemis program moved at the pace of a glacier, massive, impressive in theory, and agonizingly slow in practice. Launch dates slipped, hardware got delayed, budgets ballooned, and the dream of returning humans to the moon started to feel less like a bold mission and more like a recurring headline that never quite became reality. But everything changed with new leadership and a new philosophy. Out went the old approach, cautious, committee-driven, built around a single symbolic landing. In came something far more aggressive, a living, breathing, building strategy. One that doesn't just ask, can we get there? But asks, can we make it home? The answer, according to NASA's new roadmap, is yes. And here's how. Every great structure in history began the same way. Not with the walls, not with the roof, but with a test. A proof that what you're about to attempt won't collapse the moment it leaves the drawing board. That's exactly what Phase 1 is. Artemis 3, which many expected to be the triumphant moment of boots hitting lunar soil, has been restructured. Instead of rushing to land on the moon before everything is truly ready, it becomes something more strategically valuable. A full dress rehearsal in low Earth orbit. Every system, every protocol, every procedure stress-tested in the environment closest to the real thing before the real thing happens. Think of it like a Broadway production doing its final preview before opening night. You find the problems before the world is watching. Then comes Artemis 4. Targeted for 2028. This is the mission. The first crewed lunar landing of the modern era. But unlike Apollo, this landing isn't just symbolic. It's scouting. It's the opening move in a much longer game. And the crew won't be going alone. Deployed ahead of them, the VIPER rover, NASA's ice prospecting robot, already crawling across the permanently shadowed craters near the lunar South Pole, mapping water ice deposits that could one day become drinking water, breathable oxygen, and rocket fuel. Flying alongside the mission. A new generation of moonfall rocket drones. Autonomous, precision-capable, they can ferry small payloads across terrain no wheeled vehicle could survive. They are the moon's first logistics network, and they arrive before the humans do. But here's the challenge that determines whether any of this is actually sustainable. The lunar night. Every 2 weeks, the moon is plunged into darkness for 14 consecutive days. Temperatures plummet to nearly -200 degrees Celsius. Solar panels go dark. Batteries drain. Standard equipment fails. That's why Phase 1 also includes something that doesn't make many headlines, but might be the most important test of the entire program. Small-scale nuclear power trials on the lunar surface. Compact fission systems designed to generate electricity continuously, day and night, regardless of the sun. Crack that problem, and you've unlocked the moon. Full stop. Phase 1 proves we can get there. Phase 2 answers the harder question. Can we actually build something? Because a lunar base isn't a mission. It's a construction project. And construction on the moon is nothing like construction on Earth. You can't ship everything from home. You can't send in a team of workers with hard hats and coffee thermoses. And you absolutely cannot afford a mistake that takes 6 months and a rocket to fix that. So the strategy is elegant in its ambition. Send the machines first. Autonomous excavation units. Robotic systems designed specifically for the lunar environment. Arrive ahead of any crew to begin doing the hardest, most dangerous work. They dig. They grade. They move regolith, the loose, ancient material that covers the moon's surface to create flat foundations, thermal protection layers, and the infrastructure skeleton that future habitats will be built upon, working alongside them. Massive deployable solar, arrays that unfurl like mechanical flowers across the South Pole's ridgelines, where sunlight is almost perpetual. They begin charging the base's power grid months before a single human being arrives. And then the nuclear fission. Reactors come online, not experimental this time, operational, providing the kind of reliable, round-the-clock power that a permanent lunar base demands. The kind that doesn't flicker when a crater wall blocks the sun. The kind that keeps life support systems running, keeps communication satellites powered, and keeps the base alive through the long, dark lunar nights. But perhaps the most remarkable piece of Phase 2 is what arrives next. The pressurized mobile habitat, developed in partnership with JAXA, the Japan Aerospace Exploration Agency, and designed in collaboration with Toyota. This is essentially a lunar RV, a fully pressurized, rover-like habitat that can carry 2 astronauts across hundreds of kilometers of lunar surface without a spacesuit. Think of it as the base's exploration arm, a ship within a world, allowing the crew to venture far beyond the landing zone and survey regions no human eye has ever seen up close. By 2032. The south pole of the moon will look less like a barren crater rim and more like the very early stages of something that deserves a name. This is the moment everything before it was pointing toward. Starting in 2033, human beings will live on the moon, not visit, not explore and return. Leave. Rotating crews of 4 will arrive every 28 days. Roughly 1 lunar cycle, relieving the previous team and continuing the work of building, operating, and expanding the base. They will sleep there. They will eat there. They will conduct science there that cannot be conducted anywhere else on or off Earth. Their homes, not brought from Earth. In one of the most striking elements of the entire roadmap, the habitats of Phase 3 will be 3D printed using local materials. Robotic printers, drawing from the lunar regolith itself, will construct pressurized structures layer by layer, thick enough to block radiation, strong enough to maintain atmospheric pressure, permanent enough to last for generations. The moon building itself. And then there's the water, those ice deposits. VIPE are spent months mapping in Phase 1. By Phase 3, they're being actively harvested. The ice is melted, purified, and then, through electrolysis, split into hydrogen and oxygen. The oxygen becomes breathable air, pumped into every habitat on the base. The hydrogen, recombined with oxygen in a different ratio, becomes rocket propellant. The moon isn't just a destination anymore. It's a refueling station, a supply depot at the edge of deep space. The implications of that are almost too large to process. A base that produces its own fuel. A base that generates its own oxygen. A base that builds its own walls. This is no longer a mission. This is the first permanent human presence beyond the Earth, and it is sustainable. Here's what I want you to take away from all of this. The moon isn't the goal. The moon is the practice run, not everything. NASA is building in these 3 phases: the nuclear power systems, the autonomous construction equipment, the ice-to-fuel extraction technology, the 3D printed habitats. Every single one of those technologies transfers directly to Mars, to the asteroids, to wherever humanity decides to go next. And the generation of scientists, engineers, and explorers that this program is training right now, the ones watching rover feeds from the lunar South Pole, the ones running simulations for base pressurization systems, the ones designing fission reactors for a world without atmosphere. They are the ones who will finish what Phase 3 starts. We are not going to the moon because it's close. We are going to the moon because learning to live there teaches use how to live everywhere. The impossible has a blueprint now, and the clock is running.